June 20, January. Basically, this is January 2022 paper. Or question number one says this question is about mixtures and compounds. The box gives some methods used to separate mixtures. Choose methods from the box to answer the following questions. Each method may be used once, more than once, or not at all. So identify a method to separate a single food dye from a mixture of food dyes. Of course, you can see that it's a food dye. Dye means it's a colored species, it's a colored substance. So we can separate the colors through the technique that is called chromatography. Okay, so I would be writing that this is the chromatography. So part A1 is chromatography. Identify a method to separate gasoline from a crude oil. Of course, it's a fractional distillation. Fractional distillation. Identify a method to separate water from copper sulfate solution. So copper sulfate is soluble in water. Copper sulfate is soluble in water. So when we are going to separate the water, okay, from the copper sulfate solution, so it's called simple distillation. The diagram represents a molecule. Explain why this molecule is a compound. Why this molecule is a compound. Shafe, what do you think why this is a molecule? And how can you say why this molecule is a compound? Like why? Yes.
Sir, because the molecule, there are two molecules of different sizes. That means they're of two different elements. So it has to be a compound.
Okay. So you can say that it consists of two atoms. It consists of two different atoms. Okay. It consists of two different elements, you can say. And it's not a mixture. They are chemically bonded. They are chemically bonded. This is of 2 marks. This is of 2 marks. So you can say two elements, two elements, two elements that are that are that are chemically joined together. Okay. State the for number of different elements in this formula. So carbon, hydrogen, nitrogen, and oxygen. So means that this is 4. Number of atoms. So means 3 plus 5 plus 3 plus 9. So the total would be 20. Simple. Name two substances needed for iron to rust. Name two substances needed for iron to rust. Of course, we have the two main things that are mandatory for the rusting. Of course, the first one is air and the next one is water. Give the chemical name of rust. Iron, iron 3 oxide. Iron 3 oxide. What type of reaction occurs in the rusting of iron? So in rusting of iron, you will see that this is going to be oxidation. You know how? Because iron is Fe is going to react with oxygen and it's going to form Fe2O3 since this is an addition of oxygen. So that's why I'm saying this is oxidation. Some iron objects are coated with a layer of zinc to prevent rusting. Name this type of rust prevention. So it's galvanizing. It's galvanizing. Okay. Explain how this type of rust prevention continues to protect iron when the layer of zinc is damaged. So of course, zinc is more reactive than iron, so zinc would be reacting. Say zinc would be reacting instead of iron. So that's the reason. This rust prevention continues to protect iron when the layer of zinc is damaged. Why the layer of zinc is damaged? Zinc is higher in the reactivity series. If you can see the reactivity series, so of course, rather than iron, zinc would be reacting with the coming substances, like whatever the substance is. So it can prevent, like it can like it is going to protect iron. It is going to protect iron. So this is of 2 marks. So first of all, you have to write it down that in the reactivity series, zinc is higher than iron. So zinc is more reactive. Okay. So zinc reacts or corrodes instead of iron. Give two other methods used to prevent iron from rusting. So you can coat the iron. It's called painting. It's called painting. It's called painting, of course. And this is of 2 marks. And you can say you can you can uh you can apply oil. Okay. You can apply oil. Okay. Oiling. Okay. You can also do sacrificial protection. You can also do cathodic protection. So these are the methods you need to know. Solid to liquid. Name of change. What is this? What is this? It's melting. Solid to gas. It's sublimation. Liquid to solid. It's freezing. When ammonia gas and hydrogen gas mix, the reaction form a sodium chloride. A teacher soaked a piece of cotton wool in concentrated ammonia solution and another piece of cotton wool in concentrated hydrochloric acid. This. State the name given to the spreading out of the gas particles. Of course, they would start to spread. They would start to spread. So, what's the name of the process? Cafe, what is the name of this process? Hmm? Yes?
Sir,
No?
can you show the question again?
This one.
Sir, diffusion.
It's a exactly. It's diffusion. State how the diagram shows that the particles of ammonia gas are traveling at higher speeds than the particles of hydrogen chloride. Of course, hydrogen chloride gas is HCl, okay, and ammonia is NH3, okay. So you can say that ammonia travels faster. You can say ammonia travels faster than hydrochloric acid. You know how? Because the ring is going to form, because the ring is going to form away this ammonia. Like ammonia is going to travel more distance. It's going to cover more distance. Okay, ammonia travels further. Ammonia travels faster. HCl is not going to cover a long distance as compared to this ammonia. It shows that the speed of ammonia was higher. That's the reason. At the same time, ammonia has covered a more distance. It's very simple. It's very simple. Okay. So I would say that, state how the diagrams show that the particles of ammonia gas are traveling at a higher speed. You know what I would be writing? I would be writing that ammonia, ammonia travels Ammonia travels further. Ammonia travels further at the same time. So it is covered a long distance. So I can say its speed was higher. Gas particles travel at higher speeds. Give a reason why the white ring of ammonium chloride takes several minutes to form. Several minutes to form. You know, the thing is that they are gases. They don't travel distance in a straight line. They would be diffusing in multiple directions, just like a light. Just like when you turn on the light, of course it would be the light would be traveling in multiple directions. It's not going to travel in a mono like in one direction. Okay, so it's of one mark only. So I would be writing gas particles move in random directions. Concentrated ammonia solution and concentrated hydrochloric acid are corrosive. Give one safety precaution the teacher should take. The teacher should take, of course, wear gloves. Of course, wear gloves. Okay. Give a reason why the copper powder is heated. You have this whole method. I'm going to give you only 1 minute. So tell me the answer of part A, part 1, fast. Very, trust me, very easy. Fast. Okay, I'm telling you this. Give a reason why the copper powder is heated. You know, heat the copper powder. Push the plunger on syringe A to pass the mixture of hydrogen and argon over the hot copper so that the mixture moves into the syringe B. Argon is unreactive. It's not going to react with this copper. Of course, it's unreactive gas. Okay. So you know why we're going to heat it? Why we are going to heat this, because to increase the rate of reaction. It would take less time. If you're not going to heat this uh, like the copper, so the rate of reaction would be slower. To increase the rate of reaction. Okay, to increase the rate of reaction. Okay, state why argon is unreactive. Why argon is unreactive? Yes. Mhm. Because its outer shell is full. Outer shell is full. Outer shell is full. It will not lose electrons or gain electrons. Give the name of the black powder that forms when the oxygen reacts with, of course, copper oxide. Of course, copper oxide. Okay, then show the results. Show the all oxygen has reacted. State how the results show that all the oxygen has reacted. The table shows the teacher's results. Okay, the table shows the teacher results. Okay, so in B part 1, they are asking state how the results show that all the oxygen has reacted. So what would you write? You can see 58, 58. The reading is not going to change. The reading on the syringe is not going to change. You know what does it mean? All the oxygen is used up. All the oxygen has reacted. So you know what I would be writing? Results are the same. Results are the same. Like, or you can say of experiment 8, 9, and 10. Very simple. The volume of gas in the glass tube and connecting tubes is 175 centimeter cube. Use this value and the results table to calculate the percentage of oxygen in the mixture of oxygen and argon. Shafi, try this question, then I would be telling you this.
Okay, sir.
Yes, Shafi. Mm-hmm. Basically, I'm telling you this. This is of 3 marks. This is of 3 marks. Okay. So first of all, you know, volume of oxygen is 20 centimeter cube. Okay. Volume of oxygen is 20 centimeter cube. And then, and then, uh, you can see that uh, the total volume. You see that the total volume. Okay. Like the total volume is 253 centimeter cube. The total volume. Total volume is 253 centimeter cube. You know what you would be doing? So you have the volume of oxygen divided by the total volume and then 100, and you would be getting the percentage of oxygen. That would be, can you tell me the answer? It's very easy.
7.90, sir.
7.9%. 7.9%. Okay, suggest one reason the calculated percentage of oxygen in the mixture may not be accurate. May not be accurate. Remember, you can see that this was the apparatus. This was the apparatus. Okay, when the answer is not accurate, so means that there is some leakage. There is some leakage in the apparatus. You know. So of course, when there is a leakage in the apparatus, so I can say that the temperature would not be the same. The temperature would not be the same. Okay. So of course, when I would be taking the reading from that apparatus, so that's gonna give us the wrong reading.
So this is of only 1 mark. I need to write there. There might be there might be leakage a leakage in apparatus. Okay, there might be a leakage in apparatus. Okay, so of course due to that the temperature would be the same. Okay, for all the readings. So that's the reason the calculated percentage of oxygen may not be accurate. That's why. Hmm? Okay. Then they are saying complete the table. Oh, the relative mass of proton, it's 1. It's 1. Relative charge is +1. Okay. And it's 0. It's very easy. Magnesium has 3 isotopes. State the meaning of the term. State the meaning of the term isotopes. So isotope means atoms of the same elements. Atoms of the same elements have same proton, but different neutron.
But different neutron. The symbol for an atom of one isotope of magnesium is this. Give the number of protons. Give the number of protons and neutrons and electrons in one atom of this isotope. So you know the number of proton would be 12. The number of neutron would be 26 minus 12. That is equal to 1 and 4, like 14. And the number of electron would be 12. Same number of protons, same number of electron, different number of neutron. That's why this is an isotope. Okay, so isotope means that they would be having the same electron and proton but different number of neutron. But we are going to do a comparison between the two atoms of the isotopes. Like we have magnesium 20 and we have magnesium 26. So you would see that the proton and electron would be the same and the neutron would be different. Okay. Use this information and use this information to show that atomic mass of magnesium is 24.32. So you know what I would be doing? 24 times 79% plus 25 times 10% plus 26 times 11% is equal to so of course you are supposed to divide it by 100. Can you tell me the answer? Yes. Mm, fast. Hmm. Fast. 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 Mhm. Yes.
Say 23.53.
Okay. 1 mole of magnesium has a mass of this. There are this one atoms in 1 mole. Calculate the mass in grams for 1 atom of magnesium. Give your answer. 2, 4 significant figures. Okay, so they have given the mass. They are asking the mass in grams of 1 atom of magnesium. They are asking the mass of 1 atom of magnesium. Okay. So this much atoms is very important. Listen, this much atoms are going to have this much mass. Okay. What would be the mass? What would be the mass if I have only one atom? If I have only one atom, so X would be equal to 1 multiplied by 24.32 divided by 6.022 multiplied by 10 to the power 23. So the answer would be 1 multiplied by 2, 4.32 divided by 6.022 exponent 4.039 exponent minus 23. That's the answer. Then they are saying determine the maximum amount in moles of magnesium oxide that can be produced from this 1 moles of magnesium and this 1 moles of oxygen. This is of only 1 mark, 1 mark. So first of all, you have to see, they have given us the 2 moles. So this question is related to the limiting reactant. First of all, you have to divide. First of all, you have to identify which one is a limiting reactant. So how can we find out the limiting reactant? How can we find out the limit? It's of only 1 mark. So I would be doing short calculation. 0.5 over 2. 0.2 over 1. It would be 0.25. It would be 0.2. Okay, you know what I did? I only divided the moles with the coefficient. The moles with the coefficient. After dividing with the coefficient, I would be getting the answers. So the answer is 0.25 mole for this magnesium and 0.2 moles for this oxygen. So the mole of oxygen is lower. It's a smaller number. So oxygen is a limiting reactant. So I have decided that oxygen is a limiting reactant. Oxygen is a limiting reactant. So I would say oxygen is a limiting reactant. So now I can apply the mole ratio between oxygen and magnesium oxide. Okay, I got the moles of oxygen. That was 0.2. This would be X. So X would be equal to 0.4 mole of magnesium. The answer is 0.4. It's very simple. So uh, before going to identify like the limiting reactant, you cannot proceed this question. So how can I recognize that this question is related to the limiting reactant? So you would be provided two values of the reactant side. Generally in the mole questions they give only one value, but in this question they have given the mole of magnesium and as well as they have given the moles of oxygen, which shows that this question is related to the limiting reactant. And after getting this, you can calculate the amount of product. That's it. Okay. Describe the changes in the electronic
Yes.
configuration of the atoms of sodium and oxygen to form the ions in sodium oxide. You know what you would be doing in this? So you have to first, like sodium is a metal, so sodium has to lose electron, and oxygen is a non-metal and it has to gain electron. Okay, sodium is a metal, it would be losing electron, and oxygen is a non-metal, it would be gaining electron. After the loss of electron, sodium would be having a positive charge, and after the gain of electron, oxygen would be having a negative charge. So then they would be attracting together to form an ionic compound. Okay, so I would write that sodium sodium loses electron to form sodium plus, and oxygen gains two electron. Okay, oxygen gains two electrons. Hmm? Okay, so then after losing or gaining electrons, they both would have configuration that is 2 and 8. Okay, of course. Then after getting the charges like Na plus and O2 minus, they would be attracting together and they would be forming an ionic compound that is sodium oxide. Calculative formula mass of sodium oxide using information from the period. It's very easy and baby question. 2 multiplied by 23 atomic mass of sodium and oxygen is 16. Of course. So the answer would be 62. It's very simple. Very simple. Why solid sodium oxide doesn't conduct electricity? It's an ionic compound. It's an ionic compound. So of course, ionic compound is going to have a giant ionic lattice structure. So in that structure, the ions are held together with a very strong force of attraction. They cannot move. They cannot move from one place to another place. That's the reason they are bad conductor of electricity. Solid, specifically solid. Okay, specifically solid. So what I would be writing? Mhm. So sodium oxide has a giant lattice structure. Ions ions cannot move freely. Okay, so it would not be a good conductor of electricity. Give a test to show that the sodium oxide contains sodium ions. So of course we can do a flame test. We can do a flame test. Okay, so this is of 2 marks. Give a test to show that. So flame test should be done we'll see yellow color. Okay, complete the equation for this reaction. When sodium oxide is heated, of course it would be breaking down into the sodium metal and oxygen gas. We have to balance this, so it would be 4. It would be 4. This a precipitate is an insoluble compound formed when solutions of soluble compounds react after mixing. Different solutions are mixed in separate test tubes. Test tube 1, copper sulfate solution and calcium chloride solution. Tube 2, this and this. In which of the tubes will a precipitate form? In this test tube, what would be the product? CuCl2 and calcium sulfate. And in this tube, magnesium sulfate and potassium nitrate. In this tube, sodium sulfate and copper carbonate. Copper carbonate. Okay. So I would say this is PPT, it's insoluble, and this is PPT, it's insoluble. So in 1 and 3, I would see the precipitate. This is soluble, this is soluble. When something is soluble, so we would not see a precipitate. That would be a clear solution. A student mixes solutions amount in moles of silver nitrate and sodium chloride. The equation for the reaction is this. State the color of the precipitate. Of course, it's a silver chloride. Of course, it's a silver chloride, white color. White color. The student wants to obtain pure dry crystals of sodium nitrate. Crystals of sodium nitrate decomposes at temperatures above 300 degrees Celsius. Describe a method the student could use to obtain pure and dry crystals of sodium nitrate. Okay, this is of 5 marks. This is of 5 marks. So, Shafe, what do you think? I'm not gonna write it. We are short of time. So, but I would be telling you the detail. Okay. First of all, just think about that. What should we use? What should we do for this question? How can we separate?
How can we obtain pure crystals of sodium nitrate, that is the salt? And keep in mind that sodium nitrate is a soluble salt. Okay, I'm not gonna writing. Okay, I'm not gonna write. Only telling you because this is very easy topic. This is very easy question related to acid, base, and salt. So first of all, you have to filter it. First of all, you have to filter it. Okay, and after the filtration, then heat the solution. You know why we are heating the solution? So that the water, so that the water evaporates. So that the water evaporates, and we would be getting the salt. Okay, then we have to leave it to cool the crystals, to cool the crystals. Okay, so then we have to pour off excess liquid. Okay, pour off excess liquid. Okay, and then we would be getting the crystals of that salt. Then we can dry the crystals. After drying the crystals, I would be getting the pure salts, pure crystals. And in this question, they have mentioned that crystals of sodium nitrate decomposes at a higher temperature above this one. Describe a method the student could use to obtain pure dry crystals of sodium nitrate. Okay, you have all the ingredients, you have the reactants, you have the reagents, you have the conditions, you got the product, you have made your salt. Now the thing is that how can I get this? How can I separate this from the reaction mixture? So that's what I'm saying, that you have to filter it, then you have to heat the solution so that the water would evaporate, leaving behind the crystals of the salt. Okay, and then you have to cool down the crystals. Okay, and filter the crystals, then of course you have just separated water from it. Of course they are wet. So to dry the crystals, you can place in you can place this salt in an oven. You can place this salt in an oven so that the salt becomes like it gets dry. You can use that salt. It's very simple. Okay, then they are saying that they are saying that okay. Now, give an advantage of mixing solutions containing equal amounts in moles of silver nitrates and sodium chloride. So an give an advantage. Give an advantage. Okay. So why we are doing this? This is of 1 mark. Containing equal amounts. Containing equal amounts. Okay. So you can say that to make sure all the reactants have acted. That's it. That's it. And also to make sure that the highest possible yield of the product. To make sure we would be getting the greater amount of product. To make sure we would be getting the greater amount of product. Okay. Or you can say that to make sure all the silver nitrate, that is this. and sodium chloride has been reacted to make sure. So I would write that to make sure silver chloride and silver nitrate, sodium chloride have been fully reacted. Simple. Give the letter of a compound not shown as a displayed formula. Of course, this is not a displayed formula due to this. It's A. Give the letter of a saturated means double bond, means double bond. So I'm supposed to write C. I'm supposed to write C because they are saying with the general formula CnH2n, saturated means a single bond. Saturated means a single bond, but it's following the general formula for alkene. Of course, it's cycloalkane. Like this is the general formula for both alkene as well as the cycloalkane. Okay. Name compound E. Compound E, how many carbons? We have three. So it's propene. It's propene. Why compound A and compound D are isomers? If you can see compound D and A, so you can see that it has one branch and it's in the long chain, but they are having the same number of atoms. Okay, they are having the same molecular formula but different structure. So A and D has the same molecular formula but different structure. Complete the equation for the reaction. CH4 plus Br2. CH4 plus Br2. It would be forming CH3Br and HBr. Give the name of this. Of course, it's a substitution reaction. How can you say it's a substitution reaction? Because hydrogen is replaced by the bromine. Show by calculation that the empirical formula of a compound G is C2H4Cl. C2H4Cl. Carbon, then hydrogen, then chlorine. Carbon is 37.8, hydrogen is 6.3, chlorine is 55.9 divided by the atomic masses, that is 1, that is 12, that is 35.5. Okay, that is 35.5. So I would be getting 3.15. I would be getting 6.3. I would be getting 1.57. Then I'm going to divide it by the smallest number, that is 1.57, 1.57, 1.57. I would be getting 1. I would be getting 4. I would be getting 2. So the formula is C2H4Cl. Then they are saying the molecular mass is 27. Determine the molecular formula. You know what I would be doing? 127, that is this, divided by the MR of this compound. Okay, that is 63.5. 63.5. Okay, so can you tell me what's the answer? Hopefully this would be 2. Hopefully this would be 2. So I am supposed to multiply the empirical formula by 2. So I would be getting C4H8Cl2. That's the molecular formula. Okay, so we would be continuing the same paper. Okay, later on. So I'm going to send you the paper as well. So you are supposed to do this paper as well. Okay, thank you.